This is the second part of a lesson on indefinitely repeated games. In this lesson, we're going through an example. I'm Matt Rosu, making game theory content available all semester as I teach my class, so you can follow along for free. Please like and subscribe, and if you missed the first video, you can go to the description to check that one out. Let's go to an example of how do we solve an indefinitely repeated game. Let's go through a quick example. So two firms both sell the same product. They could price high or price low. Okay, for firms, actually colluding on prices is illegal, at least in the US and most places, but maybe it's happening implicitly. But whatever, we'll assume that this is a game that's going on. If you look at the payoff matrix, pricing high gets a payoff of 4 in each period. Pricing low gets a payoff of 3 in each period. Cheating on the agreement, though, gets you by if both are pricing high and one firm decides to price low, they get a payoff of 10. In a one-time game, both are going to price low because there's actually a dominant strategy for both to price low. If we notice here, like firm 1, it's 4 versus 10, 3 versus 0 versus 3. And it's symmetric, so it's exactly the same for firm 2. 4 versus 10, 0 versus 3. Both have a dominant strategy to price low, so we'd say the Nash equilibrium then, of course, is both price low. That's in a one-off game. If the game is indefinitely repeated and both firms play the Grimm strategy, is cooperation sustainable? That is the question we seek to answer. In order to answer that question, we need a discount factor. Let's suppose it's 0.9, and both playing the Grimm strategy, is cooperation sustainable? To determine if cooperation is sustainable, we need to look at the expected value of cooperation and compare that to the expected value of defecting. So, the expected value of cooperation, what is it? If you're in the class with me at Susquehanna right now, please pause, try to figure this out. Take at least 10, 15 minutes. If it takes you less, that's fine, but take a little time to work on it. So pause the video. Now that you've unpaused, what do we have here? So the expected value of cooperation. If you cooperate the whole time, the payoff is 4 every single period. We know the discount factor is 0.9, so it's 4 times 1 over 1 minus 0.9. Right? That is our discount factor. What does that equal? Well, 1 divided by 1 minus 0.9 is 1 divided by 0.1, or 10. 10 times 4, we see a number of 40 in there. Excel can do that for you as well. What about defecting? Now, defecting, it's a little bit different. So, a couple notes. First, if you defect, you get a payoff of 1 in the first, or I'm sorry, if you defect, you get a payoff of 10 in the first period and 3 in every other period. So you get a payoff of 10 plus 3. There's a wrinkle that we have to throw in here. And that is if you start in period 1, it's no longer 1 over 1 minus delta. So it's a very important note. If you start in period 1 with a stream of income, so the next period, what you're dealing with is delta over 1 minus delta. Another way you could think about this is you could start with 3 times 1 over 1 minus delta, but remember, you're not getting the 3 from the initial period. You've gotten 10 before. So you could take 3 times 1 over 1 minus delta, subtract 3. You'd come up with the same answer. But you could take delta over 1 minus delta, and you'd come up with that. So that's times 0.9 divided by 1 minus 0.9. And that will work out to 10 plus 3 times, end up being 27. Which gives us a total of 37. Excel can figure this out for you. I think it's good. It's often good to wrestle with it individually without having Excel come out with the answer for you from time to time. And what we see is the expected value from cooperating is more than the expected value from defecting. So the question, is cooperation sustainable? The answer is yes. The expected value is higher. So because the expected value from cooperating is higher than the expected value from cheating on the agreement, cooperation is indeed possible because both, it's in the best interest of both parties. Both parties get that payoff of 4. They get an extra $1 over the lower payoff, and they get that every single time period. And because the future isn't discounted that much, right? 0.9, each dollar in the future is still worth a fair amount. It's not worth cheating on the agreement to get that payment of 10 one time only and forego getting that payment of 1 in the future period in every single period. Hope you enjoyed this lesson. My name is Matt Rosu. I am putting out game theory lessons all semester long, so please like and subscribe and you'll get updates. I look forward to seeing you in the next video.